All right, everyone. In this section, we're going to look at some different characteristics of graphs. Now, we've covered these graphs before, so you should be familiar. Understand all these things can be moved around, so we're going to move some of them. Certain things we're going to talk about: domain and range, increasing, decreasing, even, odd. Different characteristics of these graphs that tell us a lot if we are asked to graph them. Okay, so let's look at a couple of these. First one, increase, decrease. Increase, decrease is where the graph is moving upwards or downwards from left to right. So if you look at this first one, I'm moving in the positive or upwards direction as I move left to right on this graph. So this graph is constantly increasing. Okay, now in this squaring function, if I look at this first half here, I'm moving down until I hit that point. So I'm decreasing at this point. Then I turn around and my graph is now headed up. That's increasing. Okay, so those are some of the different things we'll look at. Same thing with this cubing function. A cubing function, if you're going from left to right, I'm moving again this way. Notice how it's always moving up. That is increasing. So this is an increasing graph. Cube root, much the same. Okay, moving down. Square root, much the same. Exponential, much the same. So you can see how all these things are increasing. Now look over at the absolute value. Again, I'm moving from left to right. Ignore what that arrow right there looks like it's doing. Okay, I'm moving left to right. My graph is actually headed in this direction. So it's decreasing until I get to right here at 0. Then I start increasing again. So that's decreasing and increasing. Now, for all of these graphs, things can change. So if I were to take this squaring function, and let's say I take it and I rotate it like that. Okay, my graph now, if you look at it, it's increasing all the way to there. Then it starts to decrease. And you'll see different graphs that do some things like this, down, over, you know, whatever it happens to be. They're going to be increasing, decreasing. Now the question I have for you is, what is that? It's not going up or down. Well, that's what we call staying constant. Okay, so sometimes these things can go up, they can go down, or they can stay constant. All right, so that's one thing that you need to be aware of, is the increasing and decreasing. All right, next thing is what is called even and odd. And this one's a little bit tricky, so hopefully this makes some sense. But even and odd is based on the reflection around certain things. So if a function is even, it will look the exact same across the y-axis. So if you look at this square function, that half and this half look exactly the same. That is considered even. Okay, so even looks the exact same. So let's go through our functions that we've got here and see if we can find any. Now, if you look at the cubing function, it's not even because this half here is not reflected on that side. Okay, so that one's not even. If you go down and look at your absolute value, how about that one? Well, this half and this half are the exact same. Okay, so that point and that point are essentially just equal distance across. That's considered even. Now another test for this is to look at the points. Okay, this right here is the point 2, 2. This right here is the point 2, negative 2. If it, or sorry, I got those backwards. It's negative 2, 2. If you have the same values, but your x is the opposite. So remember, positive, negative is the difference between opposite. If I have 2 to negative 2 and positive 2, positive 2, that is even. All right, the next option is odd. And odd occurs when you have a reflection across the origin. Now, when we talk about reflections across the origin, here's what I mean. I'm going to modify this just slightly. Actually, I'm going to go here. And I'm going to take this one and move it to there. Okay, so what I have is I have this line. My origin is right here. So if I take this point and I take this point, those two things are reflected directly through here. They're equal distance across that origin. Okay, so from there to there. That's considered odd. So anything reflected across the origin is considered odd. So basically, think you're going to fold it on that line, or this line vice versa, and those are considered odd. So I want to take into account the cube function. I'm going to draw this one more time. So my cubing function, if I am very accurate, so it's going to be right there and right here, is going to look something like this. Okay, and obviously that's just a sketch, but what you need to notice is on this one I have the point 2, 8. On this one I have the point -2, -8. If I were to draw my line, those two things would be reflected. So your x and your y both switch signs. Okay, so that is odd. And even and odd is a little bit tricky. But that's kind of the point between these. So let's look at this greatest integer function. Do you think this greatest integer function is odd? Well, as you go from here to here, that works. But that point right there does not have a reflection right there, so that's not odd. Well, if it's not even and it's not odd, what is it? Well, we just call those neither. So it's neither even nor odd. We just call them neither. All right, the other big thing we've got to look at, since we've talked about increasing and decreasing, we've talked about even and odd, is domain and range. And domain and range gets messed up a lot. Now here's how you got to think about with domain. Domain is your x values. Range is your y values. So x goes left and right, y's go up and down. So this is just telling us how far up and down or how far left and right this goes. So if you look at this first one, this is a line. If this graph continued on forever, how far to the right and how far to the left would this go? Well, it would continue up, but it would always be moving right, it would always be moving left. So every number is in that domain, you'd say it's all real numbers. Okay, the range, same idea. It's always going up, it's always going down. It would be all real numbers. Okay, so the domain is the x, the range is the y. Now for the second one here, this squaring function, things change a little bit. Let's talk domain. If I continue this on, this would go down forever. And you have to kind of use your mind's eye a little bit, but those lines would always be going away from each other. So it's constantly spreading out. It may be spreading to the right and left very slowly, but it is always spreading out. Now, on the contrast, the range is the y. It's always going down, but it only goes up that high. So the range would be restricted. Okay, so we'd say, I'm going to move this up just for the ease of this conversation. Let's say the highest point that that thing gets to is 5. Well, you'd say that your range of y is less than or equal to 5 because your y value never gets higher than +5. Okay, so that's the range there. Now let's look again at this cubing function. So again, just a quick sketch of it. Looks something like that. That thing goes up forever. It goes down forever. It goes right forever, although very slowly. Same thing to the left. So your domain, your range are all real numbers. Okay, cube root, same idea. It's going to kind of look like that. It's going up very slowly. It's going down very slowly. But it's going right and left very quickly. So again, all real numbers for your domain and your range. Okay, square root. Now, square root, if you guys remember, looks something like this. Okay, so there's my square root. Does this thing go up forever? Technically, yeah, this thing will always climb. It's just going to climb slowly. Does it go right forever? Yeah, it's always going to be moving in this direction. So up and right, we're good. However, the down part stops right there. Okay, I can't go lower than 0 because you can't have negatives. The left part stops right there. It can't go left any further because you can't take square roots of negative numbers. So your domain and your range are restricted. Your domain, your x value, has to be greater than or equal to, well, look at the graph. It stops at 0. Okay, that's where my left and right movement stops. The range is, again, left and right. My range has to be greater than, well, this is up and down. It's 0. And there you go. Okay. Now, for all of these, they can be transformed. They can be moved up, down, left, right, whatever. So if I were to take my graph, and this is my square root graph, and I were to transform it to there, and that's my new square root, what's the furthest left it goes? Well, the furthest left is 3. So my domain would change to 3 instead of 0. What's the furthest down it goes? Well, the furthest down would be -2, so my range would change to -2, and there you go. So domain and range take a little thought. They can be a little bit tricky. As you get going, we're going to look at some of these functions like the square root and talk about what can and can't happen, and hopefully that helps you out. All right, the final one I want to point out, just for the ease of things, is this greater integer function. Okay, these open and closed circles throw a lot of people off. Basically, think if you were to take those two and squish them together, okay, they would fill in that circle. As long as there's no holes, they are accounting for that point. Okay, so they are accounting for that point. Now, as far as the range goes, there is a space in between them. All of this, all of this, all of this is skipped. So that changes my range because my up and down is missing quite a few values. Okay, so understand that your range is different there. Your domain would be all real numbers. Your range, however, would not be, okay, because you're skipping all those. And if you really think about what they are, I've got the number -3, I've got the number -2, I've got the -1, 0, 1, 2, 3. Those are integers. So you could say my range is just all of the integers. All right, if you need help with this, definitely ask. Okay, get in touch with me, and I will kind of clear things up hopefully a little more. Thanks.